A quick way to tell if a graph is a function is use what's called the vertical line test. That is, if I draw a vertical line any place on my graph, and that's the key, any place on the graph, and it only touches the graph once, then that makes it a function. However, if I draw a vertical line any place on the graph and it happens to touch the graph twice or intersect the graph twice, that is not a function because you would have the same domain with two different ranges. It wouldn't be predictable. If we take a look at example 4 here, we want to graph y equals 3x minus 1 and determine if the domain and range. Then I want to determine whether the equation is a function, is a one-to-one function, an onto function, both or neither. Neither would not be a function. And I want to state whether it's discrete or continuous. So let's graph 3x minus 1. So we go down 1, go up 3, and over 1. And then we draw a line going through those points. There's my graph. Now what's the domain? Well, the domain can be any x, can't it? Eventually I'll hit every x, so that would be all real numbers. The range is also all real numbers, isn't it? Because no matter what number I pick for y, there's going to be a corresponding point on the graph for that. Now, what kind of function is it? Well, every domain has exactly one range that corresponds with this. So this is both one-to-one and discrete. Or not discrete. One-to-one and onto. And then, is it discrete or continuous? No matter what pair of points I pick, I can always find a point between them. So that makes it continuous. Notice when I graphed it without picking up my pencil, or in this case pen, when I graph my line. I can graph that line in one smooth stroke. Now let's talk about independent and dependent variables. Well, independent variable is the one we change. It's the one we control. Whereas dependent it depends. I hate to use the same word in a definition, but it depends on the value of the independent variable. In an equation, the dependent variable is by itself. So if we look at our equation, y equals 3x minus 1, y depends on the value of x. Because what happens, we take x, we multiply by 3 and subtract 1. So x is my independent variable, y is my dependent variable. When we look at function notation tells us what the independent variable is, because it tells us, hey, f of x is my independent variable. F of x is going to be my dependent variable. So what happens is, it says find 49 minus x squared. So I want to find the value of f of 5. So what happens is, I'm going to replace x with 5 every place I see it. So I say f of 5 equals 49 minus, I always use parentheses when I substitute, squared. So 5 squared is 25. 49 minus 25 is 24. So f of 5 equals 24. And there's our answer. That's function notation, and we're going to evaluate function notation.